Hey, this is video 2 for lesson 1. We pretty much already learned everything we need for lesson 1 from that first video. The only thing is now we're going to do a bunch of problems where I only give you a piece of the solution and we have to figure out everything else. So in the past, we've been finding all of our trig functions from a triangle. Now, I'm going to give you a trig function, like maybe I give you this answer, square root of 6 over 12, and we have to go backwards and draw our triangle or figure out what this square root of 6 over 12 represents so that we can get the rest of these answers. What? Okay. So first it says, if tangent equals 4 over 11, draw and label a triangle and find the other trig functions. Okay, well, we know something about tangent. We do. We know that tangent from SOHCAHTOA is TOA. All right, so this 4 over 11 that we have tangent theta equal to, that represents the O opposite over the A adjacent. Okay. Let's draw a picture. So this is my first step. Usually our first step was to find that missing side, but we don't even have a picture drawn, so we kind of need to draw a picture. So first step, identify whatever they gave you. They gave me 4 over 11 was tangent. Tangent is TOA. TOA is opposite over adjacent. Okay, the angle they're talking about is theta. And honestly, we could put theta at the bottom or the top. It doesn't matter. It's how we label that's important. Okay, first, across from that 90, from that little box, or the longest side, or that diagonal, is always the hypotenuse. Yeah. Okay, then across or opposite that theta is the opposite side. And then the side at the bottom that's actually touching the same area that my theta is in, like touching it, that's the adjacent. I know my hypotenuse is also touching the area that my theta is in, but the hypotenuse is always the hypotenuse. Yeah, okay. So across from the 90 is always the hypotenuse. That means the other little side, the ones that's touching the angle you're looking for, is the adjacent. Okay, so we know our opposite is 4. From here, TOA. We know our adjacent is 11. All right. And then now we just have to figure out our hypotenuse. And then we can whip out the rest of the trig functions. So it's just like that last example, only they gave us just one of these answers, just one of these, and they expect us to draw the picture, find the missing side, and figure out the rest of the information. Okay, let's go. So that was my first step. My second step is to find that missing side. And it looks like that missing side is the C or the hypotenuse. Yeah, so let's whip out that Pythagorean theorem. A squared plus B squared equals C squared. And the C is always the hypotenuse. C is never these little legs, this base and altitude. C is never the base and the height. C is always the hypotenuse. Okay, so we don't know our hypotenuse, so keep it there. As for A and B, you can swap them around. I could write 11 squared plus 4 squared. Or I could write 4 squared plus 11 squared. As long as the C is the hypotenuse, these two numbers to the left can be swapped. Okay, so now PEMDAS says PE, so let's exponent. 11 squared, 121. 4 squared, 16. All right, let's add those suckers. You get 137. Then square root of, then we put a square root on top. to make that tiny 2 go away. And if I try and break up this 137, let's see what happens. You want to look for the perfect squares that can divide into 137. So, the perfect squares are 4, 9, 16, 25, 36, 49, 64. You get the point. Okay, so let's see if this 137 is divisible by any of these numbers. If it is, we can do something. We can simplify. If it's not, we can't simplify. Okay, so I'm going to take 137. Oops, I don't know what just happened. 137. Then I'm going to divide it by 4. And it's a decimal, so 4 is not a multiple. Okay, let's keep going. 137 divided by 9. 130. And I just keep getting decimals, which means that this 137 is probably prime. Yeah, and if I keep going all the way to, I think the next square right below 137 is 121. And even that creates a decimal. So, this sucker is prime. Or it's made up of all primes. But what it's not made up of is a perfect square. So, my C is my hypotenuse. And it's just equal to the square root of 137. Okay, so that was my second step. Now we go through the sine, cosine, tangent. We already, let's see, we know what tangent is. Hello. Now let's go to, okay, so sine of theta is O over H. Well, our opposite is 4. Hypotenuse is what we got down here, square root 137. But then you can't have square root in the bottom, so you have to multiply top and bottom by that square root. Remember, this is called rationalizing because we're taking that irrational, dirty square root in the bottom and we're multiplying it by itself. That way, it'll pop out the irrational number on top, that square root 137, and a nice, beautiful, rational number on bottom of just 137. So that's what our sine is. Let's try cosine. Cosine comes from kaka, from the SOHCAHTOA. So that's A over H. Our adjacent is this 11. Over that hypotenuse of square root 137. Then we're going to multiply by the house. And we get 11 square root 137 all over 137. Let me try and reduce this one. Okay, first off, this 137 in the house is protected. You cannot get up in it. Okay, so do not divide this 137 on the bottom with the 137 on the top. The one on the top is in a house. It's got security. It's got an alarm system. You can't get up in it. So don't. Okay, but let's try this 11 over 137. I'm going to try something to reduce. I'm going to say 11, regular divide sign, 137, enter. And it gives me something disgusting. But then you can press this math button. See it at the bottom left? Math. And then that arrow says, take me away to a fraction. Okay, enter, enter. Hey, it popped out 11 over 37. So we tried, or you know what I mean. We tried to reduce, but it popped out the same exact thing. So if you can reduce these numbers on the outside, you can, but you never ever divide into that square root with the number on the bottom. It's because that square root is like a house. It's protected. It has security and locked doors. Okay, let's go to tangent. I think we already know tangent. They gave it to us at the very beginning, 4 over 11. Remember, up here? Yeah. Okay, now let's find the reciprocals. The reciprocal of sine starts with a different letter, C. Yeah, so reciprocals start with different letters. Okay, CSC is the upside down of sine. And for sine, we could flip this aftermath, the math that happened at the end, the aftermath, or we could flip the beginning math. I think I'm going to flip this beginning math because this aftermath is so much bigger and terrifying. Oh, okay, so let's flip the beginning math. Square root 137 over 4. Hey, yo, that one's done. Yeah. And do not divide the 4 into the 137 because there's security, brinks, locked doors. Okay, let's go to the reciprocal of cosine. It should be SEC. And again, I don't want to flip the aftermath of cosine. It looks kind of scary. I mean, if you do, it's not that big of a deal. You'll still come out with the same answer as long as you did all the extra steps correct. Ooh. Okay, so instead of flipping this end, I doubt myself. So I'm going to flip the beginning because I don't always get all the steps. So let me put square root 137 on top over 11. And then, hey, that 11 is good to go on the bottom. That 4 was good to go on the bottom. Okay, now let's find the reciprocal of tangent. The reciprocal of tangent is cotangent. And that baby's nice. You just flop it. 11 over 4. Hey, nice. Okay, so if they give you a trig function, first you pick out what it was from SOHCAHTOA so that you can identify pieces of the triangle. And then it turns into a problem you know how to do. Oops. Okay, so let's try this sucker. And I don't think we're going to finish all this one. We're just going to set it up. Okay, it says if sine theta equals 3 over 5, draw the triangle, find the 5 other trig functions. Okay, well, my first job is to figure out what sine is from SOHCAHTOA. Well, it's so. So that means this 3 over 5 that represents sine that they gave us is the O over H, opposite over hypotenuse. All right, let's draw. Oops, okay, this is supposed to be a right triangle. It's kind of slanty. Oops, okay. Pretend it's a right triangle. And it doesn't matter where we put theta. I'll just put it at the bottom. Okay, and now let's identify the pieces of the triangle according to this 3 over 5. Well, across the 90, the longest side is always the hypotenuse, and that's the letter C. And hey, it was 5 today. Cinco. Okay, then let's see, opposite of that theta is opposite, and that was 3. And then that side, the leftover side, that is touching that area of the theta, that's the adjacent. And we don't know the adjacent. Okay, so now that we have our triangle labeled, my second step would be to find the adjacent. Okay, so let's remember a squared plus b squared equals c squared. And the longest side, or that hypotenuse, is always c. So our hypotenuse is c, so 5 squared. And then as for these other two guys, a and b, it doesn't matter if you swap them. So I could put a squared plus 3 squared, or I could put 3 squared plus b squared. It doesn't matter. As long as the hypotenuse is the letter c, your other two sides are the a and the b. Yeah. So I'll just say a squared plus the a squared is the adjacent. We'll pretend that's the adjacent side. Here, I'll put equals little a. And then the opposite, sure, let's put it in place of that b. Okay, let's keep going. We're going to have a squared plus 9 equals 25. Subtract that 9. Square root Hey, a equals 4. Yeah. Okay, so now that we have our adjacent, or our a equals 4, the last step is to finish those trig functions. So they gave us sine. Now you would find cosine from chi and tangent from toa and blah, 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 blah. Okay, let's look at this sucker. I see a square root 26 over 26. Okay, this should look kind of awkward because the numbers are the same. Okay, let's say that this was cosine after they rationalized it. What does that mean? Yeah, we done forgot. Okay. That means after they multiplied the top and the bottom by square root, this is what they got. So the question is, what did we have first that went, it was a fraction, right? And then what did we have first that when I multiply a square root 26 on square root 26, it pops out square root 26 over regular? So the question is, what did I have at the beginning to pop out what they gave me? Well, let's see here. At the beginning, to get a square root 26 on top, looks like there has to be a number 1. So 1 times the square root of 26 is square root of 26. Okay. What had to be on the bottom so that when I multiplied it by square root of 26, I got 26? Well, I had to have another square root. Okay, so instead of cosine being this guy, let's have cosine be 1 over square root of 26. It'll just be much easier. And the reason it'll be much easier is because of my good friend Juan. That's not a square root, so way easier. Okay, so our first step is to use cosine. Remember, cosine is caca. Okay, so we know that this square root 26 over 26 is the same thing as 1 over square root 26 after you multiply the house on top and bottom. Okay, so we could either say that the adjacent and the hypotenuse are these 26s that they started with, they gave us, or we could say that the one on top is the adjacent and the square root of 26 on the bottom is the hypotenuse. That will give you much better and easier math to work with. Okay, so we have our adjacent is 1 and our hypotenuse is square root 26. We can put the theta at the bottom or the top, it doesn't matter. But the opposite is the piece we don't have. And then the adjacent is this 1 down here. Okay, so let's do the second step would be to find the opposite. Okay, well, we're going to do a squared plus b squared equals c squared. And remember that the hypotenuse is always c. No matter what, always c. So we get square root of 26, square. And then on the other side, this a and b, I don't care what they are, whether they're 1 or this question mark, but you're definitely going to put the 1 and the missing piece right here. So I'll just say this 1 is the adjacent, or a. That kind of makes sense. So 1 squared plus b squared. And then this looks funky. The 1 squared becomes 1 plus b squared. And then for this, the square root of 26 squared, that cancels out. Those are inverse operations, or they're opposites. So we just get 26. Okay, subtract 1, we get 25. Square root, you get 5, is the opposite. And then we're not going to finish it. The third step would be to come up with your trig functions. Like sine is opposite over hypotenuse, so maybe 5 over square root 26, and then you have to multiply by the square root 26, da 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 da. Okay, I think I'm going to pause for now and come back to this.